welcome to Math Blossoms, where growing in mathematics is natural. Today's lesson topic is parallel lines and transversals. Let's get prepared. We're going to need a pencil. We are also going to need a piece of paper, and a calculator is not necessary for this, but if you have one handy, that's okay, because it might be useful if you're self-checking. Don't forget to pause the video from time to time to answer any of the practice questions, and rewind the video if you need to review anything before trying to answer the questions. Also, those people may want to get a straight edge as well, since we might be drawing some parallel lines and transversals. It might be easier if you have one, but if you don't, that's fine too. Okay, so vocabulary before we start. Let's go ahead and do our breathing activity. We're going to breathe in our nose. We're going to hold it for a count of 3 and then breathe out our mouth. We're going to do this 3 times, and let's just try to forget all those thoughts that might be cluttering up our mind, that might get in the way of our learning today, okay? So breathe in your nose. Hold it for 1, 2, 3. Breathe out your mouth. Breathe in your nose. Hold it for 1, 2, 3. Breathe out. And one more time, breathe in your nose. Hold it for 1, 2, 3. Breathe out. All right. Now, today's video is going to go over quite a few of those angle relationships that we were talking about. But before we get going with the vocabulary, let's look at this quote. It says, "Just be yourself. Let the world see the real, imperfect, flawed, quirky, weird, beautiful, magical person that you are." So even if you think you stand out, that's okay. Be proud of yourself the way you are. Everybody is different, and that is great, because if everybody was the same, it would be a lot more boring. So I'm glad everybody's different. Everybody has, good things about them and maybe things that they might want to change. But I think that it's a good thing that we're all a little unique, just like this red flower. Okay, the first word is theorem, and that's like a math law or something that holds true over time. And we study the triangle sum theorem. We're also going to study another one called the exterior angle theorem. But the triangle sum theorem states that all of the angles within any triangle is the sum of them is 180 degrees. And then vertical angles are those angles that are across from each other on an intersection, and they are congruent. Supplementary angles are angles that are either adjacent or not adjacent, but they add up to 180 degrees. Complementary angles are angles that add up to 90 degrees. A right triangle is a triangle that has 190-degree angle in it. That's also called a right angle. Adjacent angles are angles that share a side and also a vertex point. So they're kind of like right next to each other, and they're like neighbors. Now here's some angles we're going to talk a lot about today. And all of these angles, a lot of them are formed when we take a couple of parallel lines, which are those lines that go on forever, and they never cross. And then transversals are those lines that cut through them. So let me put on my pointer and I'll draw what that looks like. So a parallel line may look something like these two lines here. Okay, a little straighter than what I just drew, but you know what I mean. And sometimes you'll see these little arrows indicating that these are parallel. Okay, and sometimes you'll just have them labeled. Like, let's say this line was A and this line is B. And you would have it listed like A is parallel to B, because that little straight line symbol there means parallel. If you see something like this, that means perpendicular, where there's two right angles. But we're talking about parallel lines today. Okay, so when you have those two parallel lines and a transversal cutting through it, let me draw the transversal real quick. It forms a lot of angle relationships. Okay, so I might just go ahead and highlight some of these as we go. And some of those angle relationships are exterior, meaning that they fall outside of the two parallel lines. So I'm going to take my highlighter here. If I have a highlighter, yes I do, okay. And I'm just going to highlight the outside. So all of this outside the two parallel lines. Okay, and then all of this is inside the parallel lines. Let's say, let's change that to an orange because we're going to do, okay, so outside the parallel lines would be out here, and then inside is the white area. Now we're going to talk about alternate interior angles, okay? And what that means is they're going to fall inside the parallel lines because they're interior angles, but they're alternate, meaning that they're outside. I'm going to put one here and one here. They're on opposite sides of the parallel lines. Oh, let me change this to pointer instead. So here and here are two alternate angles. This angle here where the B, like angle B hits this transversal, and then this angle here formed by A hitting this transversal. Those are outside of the transversal, but inside of the parallel line. So they're alternate of the transversal. Okay, opposite sides of the transversal is the same as alternate. Okay, now if you had same side interior angles, okay, let's look at same side interior angles. I'll draw another one up here. Hang on. There we go. Okay, so I'm going to draw another one up here, two parallel lines of the transversal. And if they're same side interior, then I'm going to have not one here and on the opposite side. I'm going to have one here and here. Okay, so those are same side interior. And same side interior has a relationship as well. Okay, so alternate interior, that relationship when they're on opposite sides of the transversal, but inside or interior of the parallel lines, those are congruent. Those are equal to one another. Okay, if I had two on the other side, let's say I had, change my pen color again so you can kind of see. Well, no. There we go. Okay, so let's say I had another alternate interior angle here and here. Okay, so notice this angle here is on this side of the line. This angle here is on this side of the transversal line. So they are on alternate sides of the transversal line, but they're still within side or interior of the parallel lines. Those alternate interior angles are also congruent, okay? But your same side interior, like this one and this one, they're inside and they're on the same side of the transversal. Those are not congruent. Those are supplementary. They're going to add up to 180. Okay, and you're going to see as we go over a lot of these angles that they're either usually going to fall into one of those two categories. They're either going to be congruent to one another or equal to one another, or they're going to be supplementary or 180 degrees. Now, you may see same side interior angles as these names, consecutive interior and co-interior, but to be honest, I see it more as same side interior angles. I see it be named that, but if you do see it sometimes called consecutive interior or co-interior, that just means they're inside the parallel lines and on the same side of the transversal. Okay, alternate exterior angles. I'm going to change my pointer to green this time so you can, or my ink to green, so you can kind of see what those look like. So exterior angles are out here in the yellow area. So if I've got one over here, I'll color it in so you can kind of see it's that angle there. Oh wait, I was supposed to have green. Hang on. Try that again. Okay. There we go. Got some green there. Okay, so that one there. And then on the opposite side or the alternate side of this transversal is another green angle that's on the outside or the exterior of those two parallel lines. So that would be the green here and the green here. Those would be alternate exterior angles. And again, those alternate exterior are congruent, just like those alternate interior were congruent. Okay, so they're going to be equal to one another. Same side exterior angles, again, let me change my color again. I think sometimes it's just easier to see if you have a different color when you're doing this. Okay, so if I've got one here in purple, and then here Again, they're on the same side of that transversal, but on the exterior of your parallel lines. Okay, so they're same side exterior. Those are going to also be 180, just like those co-interior angles were. Okay, corresponding angles. This is probably one of the ones that is the hardest to comprehend. They are congruent, these corresponding angles. So when I get to that slide, I'll basically explain, but it's a little bit better. But let's say you had this relationship here with these two lines, parallel lines with a transversal, okay? And let's say you had another set of parallel lines with a transversal, okay? And basically corresponding angles are like, I'm going to change colors again. It just helps to see this if you have different colors. Okay, they're this, like if I were to take all of this and cut it out and like put it on top of this one, okay? So if I were to cut all this out, place it on top of this one, this angle here is going to be on top of this angle here, okay? This angle, hang on, let me do a different color each time. This angle here is going to be congruent or corresponding to that angle there, okay? And it just goes on. Basically, the ones that are on top of each other, if you were to cut it out, place it on top, you would find that, ooh, hang on, this is not working. There we go. You would find that the ones that you would that would fall on top of each other are the corresponding ones, and those are always going to be congruent to one another. Okay, so and so just keep that in mind when you have a corresponding angle. Generally, it's the top that's being cut out and placed on the bottom, but I wanted to show you that it could be just two identical parallel lines with a transversal going through it. As long as they're identical, they'll have those corresponding angles, okay? So we'll talk about that a little bit more in just a minute. All right, let's go to the essential questions. The first one is identify alternate interior angles and alternate exterior angles. Explain how we can use them to find missing angles. Identify same side interior angles and same side exterior angles. Explain how we can use them to find missing angles. And identify corresponding angles, explain how we can use them to find missing angles, okay? So again, this parallel lines and transversal is going to create a lot of different angle relationships. Now, we've already talked about adjacent angles, so we're just going to review it real quick. Two angles that share a common side and a common vertex are called adjacent angles. Sometimes supplementary angles and complementary angles are adjacent to one another, and sometimes they are not. Complementary angles, we hopefully before you watch this one, you watched the complementary and adjacent angle video. Two angles that form a 90-degree right angle when added together are called complementary angles. Sometimes complementary angles are adjacent, meaning they're right beside each other, and sometimes they are not. And then we also had a video on supplementary angles, also called linear pairs, or just two angles that add up to 180. And we are going to see a lot of supplementary angle relationships because you can have an angle relationship that is supplementary and something else. For instance, I can have alternate exterior angles, and those are both alternate exterior and still also congruent, right? Or same side interior angles. They're both same side interior angles, but they're also supplementary. Okay, so you can be more than one thing. All right, so straight angles form when supplementary angles are placed adjacent to one another, creating a straight line or a 180-degree angle. Okay, so here's supplementary angles that are right next to each other, which is what we see a lot in these parallel lines and transversals. And then here's some that are not adjacent to one another. Okay, in vertical angles, this was also in the supplementary and vertical angle relationship video. They're made by intersecting lines, and they are always congruent to one another. And they will not be adjacent either, because notice that they share that same vertex, but they don't share a wall, like this wall and this wall. Those are called rays actually, but I think of it like a neighbor with a wall or a fence in between. So like X would be adjacent to Y because they share that wall there. And just remember that vertical angles are congruent, because you do get a lot of vertical angle relationships in these parallel lines and transversals. All right, so here's some pictures of parallel lines with transversals. Lines that never intersect each other, no matter how far they are extended, are called parallel lines. A transversal is a line that intersects two or more lines, usually parallel lines. When a transversal cuts through two parallel lines, many angle pair relationships are formed. So here's an example of line AB being parallel to line CD. Okay, and then here's line M and N, and it's being sliced by this transversal here. And then there's this line 1 and line 2 also being sliced by a transversal. Now here's our first one we're going to talk about: alternate interior and alternate exterior angles. Alternate interior and alternate exterior angles are formed when two parallel lines are being cut by a transversal. Angles that are inside the two parallel lines and on alternate or opposite sides of the transversal are called alternate interior angles. Angles that are outside of the two parallel lines and on alternate or opposite sides of the transversal are called alternate exterior angles. So here's an example of some alternate interior angles. This angle Y and this angle Y, they're inside or the interior of these two parallel lines, but they are on alternate sides of this transversal. Okay, and they are congruent. So Y is going to be equal to Y. Same with this X. It's going to be equal to that X, because these are also alternate interior angles. Over here, we've got some alternate exterior angles. We have 49 and 49 down here. Notice they're outside of the two parallel lines. So that means they're exterior. And they're on opposite sides of this transversal line, which means they're alternate. So alternate exteriors are also congruent. So this 46 and this 46 is the same. And then angle A is also alternate exterior with this angle down here, 134 degrees. So they're both also congruent. One way you can kind of remember is that alternate, if it has that word alternate in it, it's going to be congruent, that relationship. Okay, so here's some example problems using these angle relationships, okay? So here's a problem where it just says find the measure of angle X. Well, since I know that 73 here and X here are alternate interior angles, I know that they're congruent. So I could just set up the angles, measure of angle 1, which is my 73, and the measure of angle 2, which is my X, is going to be equal to one another. What? Okay, that's in typo. Hang on one second. Okay, so X is equal to 73. Now, again, when I'm teaching this, I'm showing you how to set up problems to solve, but oftentimes if you know these angle relationships, you know the answer right away. Like for instance, this one's just telling you to find the measure of the angle 2y, which is this angle here. Well, I know that those two are, opposite sides or alternate sides of this transversal line, and it's inside of the two parallel lines. So I know that they're alternate interior angles. So I know that they're going to be equal. So angle 2y is going to have to equal this angle 90. And I already know that if I know the relationship, but I am going to show you how to set that up in case they ask you to show your work. And you would say, the first angle plus is supposed to be congruent. Remember, this is the congruent symbol, okay, the equals with that little similar symbol on top. If they're congruent, then we just make them equal to one another. So if they were asking you what y is equal, you would actually divide by 2 on both sides and find out what y is equal, and then substitute it back in to find out that it's 90. You don't necessarily have to do all of that, but I'm just showing you how you can prove if you know that angle relationship. Okay, so now we're trying to find the measure of angle z plus 5. And this time they're on alternate sides of the transversal, but this time they're outside of those parallel lines. So that's going to be alternate exterior. I know that those are going to be equal to one another or congruent to one another. So if I make them equal to one another, it's going to set up like this. Z plus 5 is equal to 30. Then I just need to subtract 5 from both sides and solve that equation. And Z ends up being 25. And then when I add the Z plus the 5 again, I get that angle is equal to 30, okay? And again, I already knew that this angle was going to be 30 because I know that exterior alternate angles, or alternate exterior angles, I should say, are always going to be congruent to one another. So I know, because I know that relationship means that they're congruent, okay? Same with these two. These are on alternate sides of that transversal, but outside of the parallel line, so they're alternate exterior angle relationships. This is going to be 53. I know it will be because they have to be congruent. To prove it, I would make them equal to one another, subtract my 13 on both sides, and, or excuse me, add 13 on both sides, excuse me. And A is going to be 66, and then when I plug that back in and subtract my 13, I get that a measure of angle A minus 13 is 53, which is the congruent to the other 53. Set up an equation by making the two alternate interior or the two alternate exterior angles equal to one another, then solve for the variable, substitute the variable back into the unknown angle if necessary. So if you're showing your work, you would do it this way. But if someone's just asking you, well, you know, what's that angle measurement? And you didn't have to show any work, you would just know right off the bat, well, this has got to be 30, you know. Okay, same side interior and same side exterior. So this one is not going to be on the opposite side of the transversal. This is going to be on the same side of the transversal, okay? Same side interior and same time exterior angles are formed when two parallel lines being cut by a transversal. Angles that are inside the two parallel lines and on the same side of the transversal are called same side interior angles. Angles that are outside of the two parallel lines and are on the same side of the transversal are called same side exterior angles. Same side angles that are interior angles can also be called consecutive interior or co-interior. Now, again, I'm not going to use those terms, but sometimes I will find those terms in textbooks and on certain written worksheets that I give students to practice with. So just try to remember that there are other names for this same side interior angle that you might see. So here's some examples where 1 and 2 are on the same side of this transversal and they're inside of the parallel line. So that's going to be interior same side over here. And then the blue as well, 3 and 4. So I know that when they're on the same side of the transversal and inside, they're going to be supplementary. They're going to be adding together to make a 180. Okay, so you know, you would just add the two angles together, make it equal to 180, and then solve if you had a variable there and they were asking you to solve. Here, same thing. We've got, but this time they're outside of the parallel line, so we call those same side exterior angles. And again, the ones on the same side, they're not congruent, they're supplementary. Okay, so remembering which of these angle relationships are congruent and which are supplementary is very key to solving these problems. Okay, so if you can remember that the ones that are on alternate sides of the transversal are going to be congruent, then the ones that are on the same side of the transversal are going to be supplementary. Okay, which means I'm adding those up and they should equal 180. Here's some example problems with this. We have the measure of angle 1 and the measure of angle 2 has to equal 180 because these are both same side interior angles. And then I would solve and get x equals 107. Yes. So so if you're just trying to find the measure of angle x, it has to be 107 because 107 plus 73 is 180. Now here we have again two angles that are inside of the parallel line, so they're interior. on the same side, or excuse me, these are not on the same side of the transversal. I need to move that. Hang on one second. Okay, so now I've moved it to where they're on the same side. So 2y and this 90-degree angle, both of those are on the same side of the transversal now, but still inside the two parallel lines. So they are same side interior. So if you were going to set that up, let me put the first one back again. Okay, you would add the two angles together, make it equal to 180. And then you would solve that two-step equation by subtracting 90 from both sides, dividing by 2 to get rid of that coefficient, and finding out that y is equal to 45, and then plugging that back in. 2 times y is equal to 2 times 45, which is 90. Okay, so again, I know that this side over here was 90, so this side over here had to also be 90, not because they're congruent, but because they both add up to 180. They're supplementary, and 90 plus 90 does equal 180. Okay, now on the third one, we have two same side of the transversal angles, but they're outside or exterior of the parallel lines. Again, we would solve those by adding them together, making them equal to 180. And then you would combine those like terms, that 5 and that 30 there is going to make a 35. Subtract your 35 from both sides, and z is going to be 145. Z plus 5, however, is going to end up being 150. Okay, so again, I already know that this has to be 150 because I know 150 plus 30 is 180. And I know that because they're same side exterior angles, they have to equal 180. These two are also same side exterior of the parallel lines, but on the same side of the transversal. And so we're going to add them up and make them equal to 180 because we know they're supplementary. And we're going to combine these like terms. So minus 13 and then a positive 53 added together gives us a 40. Okay, then we're going to subtract the 40 from both sides and find out that a is equal to 140. Then I take that a, substitute it back in, subtract that 13 from it, and a is going to, the measure of angle a minus 13 is 127. And I know that it's 127 because 127 plus 53 is that 180 relationship. So set up an equation by adding the two same side interior or exterior angles together, making them equal to 180. Solve for the variable, substitute the variable back into the unknown angle if necessary. Okay, so corresponding angles. These are angles which occupy the same relative position at each intersection where a straight line crosses two others. If the two lines are parallel, the corresponding angles are congruent or equal to one another. Okay, so here we have some examples of corresponding angles, and it does help to see when they're color coded. So you can see this angle relationship of these four angles are identical to these angle relationships. Okay, and so if I were to just take, and cut this out, place it on top of that one, my 8 and my 4 are going to be right on top of each other, and those are corresponding angles. My 5 and my 1 are going to be corresponding, my 7 and my 3 and my 6 and my 2. And corresponding angles are always congruent, so they're always going to be equal to one another. Same with over here, our 1 and our 5 are corresponding, our 3 and our 7 are corresponding, 2 and 6 are corresponding, then this 4 and this 8. Again, if I were to cut all of that out, pick it up, place it on top of this, that 1 would be on top of that 5, that 2 would be on top of that 6. Do you see? Because that is how I best remember which one's corresponding. I imagine myself cutting it out and then placing it on top. And so I'm just drawing you a visual here to see how that works. And then you can see which ones are congruent to which ones, to the other ones. Okay, corresponding. All right, so congruent or supplementary. We're going to recap everything before I let you try this on your own. So again, some of these angle relationships that are formed by these parallel lines and transversals are going to end up with congruent angles, and some are going to end up with a supplementary relationship where they add up to 180. So here's just a snapshot. Our vertical angle relationships, we already know from the vertical angle relationship video that those are going to be congruent, okay? Alternate interior, alternate exterior, also congruent, okay? Corresponding, also congruent. On the supplementary angle relationship side, you've got, of course, supplementary pairs or linear pairs. You've got same side exterior and same side interior, okay? So this might help you remember when we try to do this on our own, okay? So let's try it, okay? Let's do some corresponding angle relationships first, okay? Here's some examples. Corresponding angle relationships are congruent to one another. So we know that this one here just has to be congruent to that one because they are corresponding. Here we have two corresponding angles, so they have to be congruent to one another. Make them equal to one another. Solve to find what y is, and substitute it back in if you're asked to do that to show that indeed angle 2y is equal to 90 as well as the original 90 degree over here on the left. Okay, again, corresponding angles, if I were to take this intersection, pick it up and place on top of this intersection, that 30 would be right on top of that z plus 5. They're supposed to be congruent, so make them equal to one another. Solve to get what your z is equal to, and then substitute that back in. The 25, adding the 5 makes it a 35. And I know that 35 plus, should be 30. Something went wrong. Something went amiss here, because that should be a 25. Let me fix that. All right, so the last one, this should be 30 down here, by the way. The last one over here, we have same side exterior angles. They're also corresponding. Actually, I need to move one of these to make them corresponding because they're same side exterior, but they're not corresponding. This 53 needs to be up here. So let me check that out real quick. Okay, so we made them congruent to one another because we know corresponding angles are congruent to one another. And so when I do that, I end up with a minus 13 equals 53. Subtract my 53 from both, or add my 53 from both sides, excuse me. A is going to be 66, and then when I substitute that back in, subtract that 13 from it, that angle up above is also going to be 53. So again, if you know that corresponding angle relationships are congruent, then you already know the answer to that angle. But if they're asking you to show your work, definitely show your work, show that you know how to do it mathematically. Set up an equation by making the two corresponding angles equal to one another. Solve the variable and substitute the variable back into the unknown angle if necessary. All right, so let's try this. All right, so I'm going to ask you to pause and identify the angle relationships between x and y for both of these. Are they congruent or are they supplementary? So pause. 1, 2, 3. Okay, angle x and y are on the same side, interior angles, so they are supplementary, which means they add up to 180. On the second example, x and y are alternate interior angles, so they are congruent, which means they are equal to one another. Okay, identify the angle relationships between x and y. Are they congruent or are they supplementary? Second blossom, go ahead and pause and try this on your own. 1, 2, 3. Okay, x and y, angle x and angle y are alternate exterior this time, so they are congruent, which means they're equal to one another. And then the second example are corresponding angles, so they are also congruent, which means they're equal to one another. Okay, third blossom, identify the angle relationships and then solve for the x and y this time. Pause. 1, 2, 3. All right, two angles are alternate exterior angles, so they are congruent or equal to one another. So I made them equal to one another, solved for my x, then plugged that, we just needed to solve for x. That's all they asked us to do. Okay, on the second example, we're solving for y this time. And the two angles this time are alternate, that should say interior. Let me fix that. All right, so on the second one, y is going to end up being 37. Oops. Well, my computer's, there we go. All right, fourth blossom, identify the angle relationships and then solve for x and y. So pause. 1, 2, 3. First one, the two angles are on the same side interior angles because they're inside those parallel lines. So they are supplementary. So we're going to make them, add them together, make them equal to 180, solve the equation for x, and x is going to end up being 130. On the right side, we have corresponding angles, which are, hang on one second, that's not right. All right, so yes, they are exterior angles. And so we would have to understand that they are going to, because they're on the same side of the transversal, they're going to be supplementary. My mouse is locking up today for some reason. And so because they're supplementary, we're going to make them equal to 180 and then solve. And so y is going to end up being 123 degrees. All right, so let's look at our next essential question. Identify alternate interior angles and alternate exterior angles. Explain how we can use them to solve for missing angles. Pause. 1, 2, 3. Angles that are inside two parallel lines and on opposite sides of the transversal are called alternate interior angles. Angles that are outside of the two parallel lines and on alternate opposite sides of the transversal are called alternate exterior angles. Set up an equation by making the two alternate interior or exterior angles equal to one another because they are congruent. Then solve for the variable. Substitute the variable back into the unknown angle if necessary. Okay, essential question number 2. Whoa. Oops, sorry about that. Go ahead and try to solve this one, or try to answer it. Pause. 1, 2, 3. All right. So angles that are inside the two parallel lines on the same side of the transversal are called same side interior angles. Angles that are outside of the two parallel lines and are on the same side of the transversal are called same side exterior angles. Set up an equation by adding the two same side interior or exterior angles together and make them equal to 180 because they are supplementary. Then solve for the variable. Okay, again, what is going on with this? I wish I had more time to proofread these before I record myself doing this. Okay, identify corresponding angles and explain how we can use them to find the missing angles. So pause and try to do that one. All right. So the angles which occupy the same relative position as at the intersection where a straight line crosses two others. If the two lines are parallel, the corresponding angles are congruent or equal to one another. Set up an equation by making the two corresponding angles equal to one another because they're congruent, then solve for the variable. All right. Ooh, this cute little raccoon. He's adorable. Okay, let's review our vocabulary real quick one more time. Theorems are those universal truths in math that we can prove over and over again. They're like laws in mathematics. Triangle sum theorem states that there's 180 degrees in every triangle. Vertical angles are those angles across from each other on an intersection that are congruent. Supplementary angles are two angles that add up to 180 degrees or a straight line. Complementary angles are two angles that add up to 90 degrees. Right triangles are triangles that have 190-degree angle inside. Adjacent angles are angles that are right next to each other. They share a common side and a common vertex. Exterior and interior angles. Exterior is on the outside of something. Interior is on the inside of something. And that something could be a triangle, a square. It could be parallel lines, for instance. Alternate interior angles are those angles that are on alternate sides of the transversal, but inside of the parallel lines. Same side interior angles are on the same side of the transversal, but interior of the parallel lines. Also called consecutive interior and co-interior. Alternate exterior angles are those on the alternate side or opposite side of the transversal and exterior of the parallel lines. And then same side exterior angles are on the same side of the transversal, but exterior or outside of the parallel lines. And this actually should say not consecutive. I have consecutive up here. This should say corresponding. Let me fix that. All right, so corresponding angles are those angles that are in the same relative position of the intersection. If you were to take it and cut it out and place it on top of the other intersection that's formed by the transversal, they would be right on top of each other. And corresponding angles are also congruent. And then parallel lines and transversals, of course, are the parallel lines are those lines that never cross. And then transversals are those lines that slice through the parallel lines. We use parallel lines and transversals a lot when we're in map making and city planning. A lot of your street layouts are in parallel line form with transversals slicing through them. And you'll find that in real life there. A bouquet of math blossoms have opened up in your mind today. So to further improve your math language skills, remember to practice. Study 10 minutes a day. Ask for help if you need it. Learn from those mistakes and always try. I'm Miss G, and I want to thank you for watching this Math Blossoms video. And the next video, if you have not watched it yet, is triangle sum theorem. If you have watched that one, then go ahead and do the exterior angle theorem. But I appreciate you watching today. Hopefully you learned. This was quite a long one, and it had a lot of different relationships going on. So this may be one you need to watch a couple times to remember. And if you need help, don't forget to ask your teacher, ask a study buddy, or somebody to help you. Or, you know, flashcards are wonderful if you're trying to memorize which ones are congruent, which ones are supplementary. Sometimes just writing the name of the angle and a picture of it and then flipping it over and seeing if it's congruent or supplementary, that can sometimes help you memorize which ones are which, and also what they look like, which helps a lot. So now it's time for me to say it was lovely teaching you math today. Bye.